guys. Good morning. Very good morning, everyone. So please confirm if you can hear me properly. All right. Very good morning. Good morning, guys. Good morning. Okay, so as you can see, we are going to start our name reaction marathon really, really soon. Just waiting for your friends to join up. Okay. Very good morning, everyone. Good morning, guys. Good morning. Okay. So basically, guys, what are we going to discuss in this session or in this series? What happens is, अभी देखो name reaction marathon series शुरू हो गई है, which means we are going to study the name reactions, and along with that, we are going to also solve some MCQs, right? Because without practicing, there is no benefit of studying, right? So this is what we are going to do. We will study some important name reactions today, and we will solve questions on them. All right? So ये देखो. Also, guys, you can follow me on Unacademy, and there I am teaching for CSIR net. And usually, I teach all the important topics of organic and inorganic chemistry. So, this one course has started from June 22, and you can also find plenty of important topics by other educators on Unacademy. So, if you are interested to join up, you can use the code Jagriti S Live, and you can join up after getting a 10% discount on using this code. Alright, guys, mock tests are going to start really, really soon. Yes, and also about the free sessions, guys, there are plenty of free sessions going on. Just like YouTube, you are going to see me on YouTube every Friday and Saturday in the morning, same time, 9:15. ठीक है? And on Sunday, guys, that is tomorrow only, I have kept a session. All right, and that is just for all of you because you were asking me कि मैम और inorganic का आपने बता दिया all the important topics. What about the important topics of organic and physical? ठीक है, so that is what we are going to discuss in detail in tomorrow's session. Again, the same time, right? 9:15. So I will provide you the link in my Telegram group. And this was about the YouTube session. और ये क्या है guys? Battle of polls. Already battle of poll is going on. मतलब कि question practice sessions, free question practice session on all of these topic: pericyclic photochemistry, organometallic, bioinorganic, carbohydrate, and amino acids. Right? So all of these important topics are going on every day 6 p.m. on Unacademy. All right. So do join up, guys. These are all free practice classes, 1 hour sessions. Good morning. And also, if you want to get regular notifications, then you can join up on CSIR-NET 2022. This is my Telegram channel. All right, this is the name of my Telegram channel. Chalo. So before starting, guys, let me just show you some questions. ठीक है? So हम questions तो हम करने ही वाले हैं at the end of the session. First we are going to study, then we are going to solve those questions. I am just showing these questions to all of you. पहला question ये है, major product formed in the following reaction is. क्या करना है? Look at the reagent, look at the substrate, and look at the reagent. What can happen? This we are going to discuss. Yes. Then there is another reaction. You're having the nitrile oxide and only heat and nothing else. This is what we are going to discuss. Major product formed in the reaction. Yes. You have a carbonyl and hydroxylamine and acyl chloride. Okay, so ये हमारा एक और reaction है which we are going to discuss. Or look at this, major product formed in the following reaction. Once again, you have the hydroxylamine, right? Basically, you have the oxime over here, and in the presence of acid, what can happen? So these are the reactions. These are 4 reactions that we are going to discuss. No, Dipanshu, be careful, not Martin McCombie. All right, be careful. Yes. And one more important question. ये देखो. This is also what we are going to discuss. So ये क्या हो जाएगा guys? Practice as well as revision. So first of all we are going to start with this name reaction. You also call it xanthate pyrolysis. Xanthate pyrolysis बोलो या चुगेव एलिमिनेशन बोलो. Yes, very important. Xanthate pyrolysis or chugave elimination. Very important reaction. Okay guys, so let's begin. See, what is given guys? अगर एक alcohol दिया है इस तरीके से R CH2 CH2 oxygen, and this is your alcoholic group. All right, this is your alcohol. So let's say I am taking a base, sodium hydride base ले लिया मैंने. I can take some other base also. ऐसा नहीं है कि यही OH को deprotonate करेगा. I can take any other base which can deprotonate the hydroxyl group. Okay, deprotonate करके क्या करना है? I have to take carbon disulfide over here and let's say methyl iodide. These are the three things that you are going to see. इसको देख लिया अगर आपने ये combination, if this combination you see somewhere and you see an alcohol, absolutely this is going to lead to xanthate ester formation. I'm not saying कि ये elimination reaction ही है. No, it is going to lead to xanthate ester formation, isn't it guys? कैसे बनेगा xanthate ester? See, O becomes O minus. O minus is going to attack to carbon disulfide and it is going to further attack on methyl iodide through the sulfur. ऐसे करके I minus leaves. You have R CH2 oxygen, then one carbon over here, one double bond S, और ये क्या हो गया SME. This is the xanthate ester that we are talking about. This is the xanthate ester that we are talking about. Yes, तो xanthate बनेगा, ठीक है. All right. Now what can we do guys? If there are two conditions, yes, in which we have to be really careful. दो कंडीशन कौन से हैं? इफ हीट इज गिवन, देखो इन द क्वेश्चन यू माइट बी गिवन सम ऑर्गेनिक सॉल्वेंट, जैसे ग्लिसरॉल हो गया. You can get glycerol, you can get xylene, you can get N-hexane, right? So all of these hydrocarbon solvents are basically those जो कि high temperature withstand कर सकते हैं. You are going to do heating and reflux, just that. So you take a high boiling solvent. Okay, तो ठीक है, मैं ले लेती हूँ यहाँ पे. Let's say I'm taking the xylene. Okay, no problem. Now what is going to happen? Just heating it. So when you are just heating guys, you are going to write the molecule in this way. All right, sulfur and Me, that is your sulfide. You are going to cause syn elimination. लेकिन एक बात बताओ, ये जो syn elimination है guys, this is also beta elimination only. Syn elimination, that is, it is also beta elimination, that is the hydrogen and the sulfur. Yes, so these are the two groups which are going to eliminate. एक तो hydrogen from this carbon and from the other carbon, this is carbon oxygen bond. So this is going to eliminate. But what happens is they are from two different carbons. So ये syn beta elimination है. तो ये देखो, it goes through a 6-member transition state in this way. Goes through a 6-member transition state. You are going to get this alkene. From the alcohol, you got this alkene. Along with that, this whole molecule is going to break down. See, what do you have? You have one carbon oxygen double bond. ये हो जाता है यहाँ पे SH and this is SME. All right. So this bond is going to break apart further and you are going to get carbon monoxysulfide in this case and methyl, or that is your thiol molecule. All right. So you get a thiol molecule, carbon monoxysulfide, ये हो गया आपका alkene. So basically what just happened, you are getting the alkene as a product from the alcohol in this way. And this elimination is known as xanthate pyrolysis. That is, in the presence of heat. In the presence of heat, you are doing the pyrolysis. ठीक है? So this is what we have to be careful about. अब ये reaction तो हो गया. इससे similar एक और reaction है guys, which also requires xanthate formation. ये देखो. CH2 oxygen. Yes, good morning Vishnu. Good morning everyone who are joining now. Let's say you have the same xanthate ester, but this time I am not providing heat, not providing heating condition. मैं क्या कर रही हूँ? I'm providing tributyl tin hydride, that is your TBTH, and AIBN, azobis isobutyronitrile. This combination guys, TBTN और AIBN, ये करते क्या हैं? They provide you tin radical. Yes or no? They'll provide a tin radical. What are you going to do with the tin radical? This radical is going to attack on the sulfur in this case, and एक बॉन्ड यहाँ से खुल गया तो एक इलेक्ट्रॉन इधर जाएगा कार्बन के ऊपर, राइट? और फिर क्या होगा? कार्बन ऑक्सीजन बॉन्ड फॉर्मेशन विल टेक प्लेस. यस, yes, this is your deoxygenation reaction. एक radical इधर बन गया, right? So what do I have? I have C double bond O, I have S, SN, tributyl group, SME. So this is going to break down once again, and this is going to finally give you the same molecule COS और उसके साथ में tributyl tin SME, sulfide group over here. All right. And what about this radical? This radical is going to take one more hydrogen, all right, from this hydrogen source, and it becomes alkane. So guys, what just happened? If you had started from the alcohol, CH2CH2OH, if you started from this alcohol, you have made the xanthate. Yes, if you are providing this TBTH combination and AIBN combination, right, you are going to get the alkane. इसको हम क्या बोलेंगे? Barton-McCombie deoxygenation reaction. Absolutely. ठीक है, this is your Barton-McCombie deoxygenation reaction. So be very careful when you see the xanthate. आपको ये देखना है xanthate के बाद क्या हो रहा है. You have formed the xanthate, very good, but is it going to be heating so that you get the Chugev elimination, or is it going to be the radical mechanism to give the deoxygenation? Yes, this makes sense. Very well. Now we are going to see a similar reaction guys, जिसको हम बोलते हैं cope elimination. Yes, I hope you remember, all of you guys, cope elimination. What is cope elimination guys? Let's say you had a amine like this, right? You have an amine in this way. तो ये amine क्या करेगा? I am doing metachloroperbenzoic acid oxidation of this amine, right? What does this do? हाँ, ये देखो, metachloroperbenzoic acid. What does it do, guys? It transfers an electrophilic oxygen. It transfers an electrophilic oxygen, which means कि ये क्या कर देगा? N, हाँ, oxidation, N oxide बनाएगा. It has formed the N oxide. Now once again I will be heating this mixture, and this is once again pyrolysis. तो क्या होगा guys? You can just write this hydrogen over here. ये जो hydrogen है, इसको आप ऐसे लिख सकते हो. The O minus is going to take this hydrogen, bond falls up over here, and the amine group is going to leave. What do you get? RCH double bond CH2. This is what you get, and along with that, ये देखो, N, R2 and OH. Yes, ये भी syn elimination है. This is also Syn Pyrolytic Elimination. Very good. This is also Syn Pyrolytic Elimination, but which reaction, guys? This is cope elimination. It goes through the N oxide and also goes through a five-membered transition state. It is not a six-membered one. Five-membered transition state, always remember, will give you Hoffman alkene. कभी भी ये क्या करेगा, सेड्स एल्कीन नहीं देगा. Always remember this important point, guys, that it is always going to give you Hoffman alkene. To give elimination, guys, this is also going to give you Hoffman, but in some cases where there is a possibility कि less hindered वाला जो proton है वो more substituted alkene दे रहा है, so in that case to give elimination goes through a six membered transition state. Over here it might still give you Hoffman and mixture of SAIDs F, right? क्योंकि six membered stable transition state है, right? However, cope elimination always Hoffman product. Okay, always Hoffman product you are going to get through this. Very, very important reaction, cope elimination. Okay, we have identified this. We have revised this reaction. अब हम चलेंगे दूसरे reaction के ऊपर. Let's look at Beckman rearrangement. Alright guys, Beckman rearrangement. So what is Beckman rearrangement? Let's say I am having this molecule. Alright, let's say I'm having this molecule. What is this? It's a ketone. Yes, ketone को मैंने क्या करवा दिया? I am making the ketone react with the hydroxylamine. What will happen? Both of these protons will be lost and this oxygen will be lost. You are going to get the oxime from over here. You will get the oxime from over here. Alright? Yes. Now what happens, guys? ये देखो oxime क्या है? Oxime के पास में lone pair है. Yes. So now in the presence of H plus, see, you can take any of these. You can take a proton H plus. उससे क्या होगा? This OH will become OH2 positive, becomes a good leaving group. First, okay, acid you can take. Second thing, you can also take tosyl chloride, no? Yes or no? Tosyl chloride भी ले सकते हैं. OH will become a good leaving group. It will become OTS. Yes. So yes, that also does the job, isn't it? You can also take BF3, isn't it? That is a Lewis acid, protic acid low ki Lewis acid low. This OH will become a good leaving group, right? Very good. Then what else can you take, guys? You can take acetic anhydride या फिर acyl chloride. Both of these you can take because this OH will become acetate, which is also a good leaving group. तो हमें OH को good leaving group बनाना है irrespective of anything else. Yes, we can do that by so many ways. चलो ठीक है, हम तो फिलहाल प्रोटॉन ही ले लेते हैं. But I hope that you understand that so many of these could be given. And also, guys, fifth number, how can I forget? You can also be given PCl5. PCl5 भी आता है. Yes, Dipanshu, absolutely. Yes, you can just convert this group into OPCl3 and it can be a good leaving group, right? So anyhow, you just have to make this oxygen a good leaving group. चलो ऑक्सीजन का तो हमने देख लिया. This is a good leaving group. Now what? Now the molecule is going to this water molecule is going to eliminate, and the nitrogen will have a positive charge. Nitrogen does not want to have a positive charge, तो एक group को migrate करना पड़ेगा. But that is the question. Who is going to migrate? So always the trans group will migrate. Always. Always the trans group is going to migrate. But a problem ये, how do we know, ma'am, कि trans group कौन सा है? isn't it? How are you going to know which is the trans group? So guys, ये देखो, very very simple. When you are having the OH2, OH2 is a leaving group, ठीक है? It will try to stay away from the bulk of the molecule. ठीक है, मतलब कि ये देखो यहाँ पे क्या है, फिनाइल ग्रुप है ना. So if I draw this OH in this way, that would be wrong. मैं ऐसे लिखूँ तो ये गलत हो जाएगा. OH will want to stay away from the bulk, तो यहाँ रहेगा OH, ना कि यहाँ पे, right? So who is trans? This carbon is trans. This is going to migrate in this way. Alright, that is what you have to just take care of. Okay? Keep the OH away from the bulk, और फिर आप directly कर सकते हो. So this is what we are doing. These two groups are anti-periplanar या फिर trans to each other, and you are going to migrate this group. Sometimes it is going to migrate on this bond, sometimes on the nitrogen. We will see both the possibilities. तो चलो लेट्स अज्यूम कि इस ग्रुप ने नाइट्रोजन पे माइग्रेट कर लिया है. आई एम राइटिंग दिस एज अ पीएच ग्रुप, दिस वन. Okay, what will happen, guys? Your nitrogen is now included in the ring. Are you going to have a 7-member ring? Absolutely. So you will have a 7-member ring over here. Nitrogen से पहला bond बनेगा. Nitrogen, one double bond over here. This carbon over here will get the positive charge. Okay, and the rest of the molecule is as it is. Yes. अब करवाओ water से attack. What will you get? You still have the 7-member ring. But you have OH over here. Right? So what will happen, guys? OH ना क्या करेगा? Tautomerism करेगा. After tautomerism, it is finally going to give you this kind of a molecule, a 7-membered ring having a amide bond. इसको हम क्या बोलते हैं? Lactam. This is what we call as lactam, isn't it? So this is your phenyl substituted 7-membered lactam को बोलते हैं caprolactam. Okay, so caprolactam molecule phenyl substituted over here. तो ये हो गया guys Beckman rearrangement. That is, we are just doing the rearrangement over here. We are eliminating the oxygen group, and one alkyl group migrates on the nitrogen. Very good. This is very simple. All the selectivity done. ठीक है, एक तो selectivity होती है कि ये OH है, ये कैसे लीव करेगा, which group is present. All right, second is trans group is going to migrate. Yes, this is it. Sometimes when you are looking at the Beckman rearrangement reaction, let's say this is your molecule once again. ये देखो, अभी हमने क्या देखा था? We just saw this molecule. Yes. All right, very good. We saw this molecule. लेकिन अगर हमारे पास ये वाला molecule है in this way. All right, in this way, let's say we have one molecule, or let's say ये देखो 2CH3 group I have written over here. Once again, the same thing I will repeat. NH2OH. Once again, I'll do this same thing. I am, let's say, converting this to PCl5. ठीक है, PCl5 से conversion. What would you get, guys? In the first step, you will get CH3, CH3. In the first step, you will get N oxygen. Now this oxygen is converted to PCl3, right? या फिर PCl4 लिख लो इधर, because when one of the bond breaks, then you are going to say PCl3. ठीक है? So in this case, what happens? Usually ऐसा होना चाहिए ना, that this bond is going to migrate over nitrogen and the oxygen is going to leave with PCl4 to give you O double bond PCl3. Yes, and ये ऐसा कुछ होना चाहिए. Yes, once again a 7-membered ring must form. Yes, after the migration, But this does not happen. You are not getting a 7-membered ring. Instead, what do you get, guys? The ring is breaking down, isn't it? Yes, the ring is going to break down. Why does the ring break down, guys? ये देखो, ring will break down. You are getting a nitrile over here और इस तरफ क्या बन जाएगा? Carbocation. This side you are getting a carbocation. Why is this reaction taking place in this way? What is this called? ये हो गया Beckman fragmentation. इसको abnormal, इसको ना हम लोग BSc तक भी abnormal Beckman बोलते रहते हैं, but guys, if you directly call it Beckman fragmentation, it would be really good for all of you to have more clarity. ये abnormal Beckman तो है ही, but ये abnormal क्यों है? क्योंकि fragmentation हो रहा है इसीलिए. ठीक है? Why does this happen? Because of a stable carbocation formation. ये देखो 3 degree carbocation is a stable carbocation. So that is why you are not getting the rearrangement, you will rather get a fragmentation. Okay? Yes. Very good. Now what happens with the fragment? अब इसका क्या होता है guys? Usually the carbocation is very stable. It is going to lose a proton from the medium and you are going to get the alkene in this way. ये हो गया आपका major product. Alright? So this is Beckman fragmentation reaction. Why do you have a fragmentation? Only when you are having possibility of a very stable carbocation, then you do the fragmentation. Also that increases the bulk in the molecule. So fragmentation is also favored. Okay? Yes. Very much favored in the presence of bulk. Alright. So all these questions are, all these name reactions are understood to all of you. एक name reaction और है, and then we collectively do all the questions. ठीक है? What is that name reaction? Let's see. Shapiro. Yes. Shapiro name reaction, last one, and then we are going to continue with the question. So guys, what do you remember when we are saying Shapiro? Yes, guys, keep on messaging in the live chat. क्या याद आता है Shapiro reaction से? Yes. क्या याद आता है guys Shapiro reaction से? Butyl lithium 2 equivalent and some electrophile. Yes, it's not necessary that you always get DMF only. Yes, lekin any other electrophile would also do, right? So Shapiro reaction would proceed. One carbonyl. In the first step, you will get tosyl hydrazone. In the first step, you will get the tosyl hydrazone. All right. ये hydrazine से hydrazone बन गया in the presence of an acid. Very well. Second step, you are having butyl lithium. Yes, Chetan, very good. So, butyl lithium, guys, you're having two equivalents of butyl lithium. This is of utmost importance. Why? Because one proton is going to make the tosyl eliminate in this way, and the second proton from here, this is also going to be removed. So, I am directly writing what I get. Tosyl is eliminated, और ये proton निकल गया यहाँ से. You are going to have a negative charge on this nitrogen. This is how it works. And then when it falls back, ये पूरा nitrogen eliminate हो जाएगा, minus nitrogen, and this is what you have. Okay? And in the presence of DMF, what is DMF, guys? It is dimethyl formamide. Okay, DMF. So DMF के ऊपर guys, this carbonyl is going to be attacked and the nitrogen is going to leave. You are going to simply get this molecule formylation over here. However, this is not such a simple reaction. Why? क्योंकि आप ना एग्जाम में कंफ्यूज होते हो कि हमें ये कहाँ पे लगाना है this CHO. That is why you don't have to do this direct. Do the mechanism, guys. ये कहाँ लगाना है हमें? We are going to do this on the same carbon where the CHO was connected. Okay, so you are definitely going to remove a proton either from here or from here. अभी ये simple example है, no selectivity over here. Very simple example. So इसीलिए मैंने double bond बना दिया, and on this carbon that is the same position, ipso position, you are going to cause the attachment of the electrophile. Very, very simple reaction, Shapiro reaction. Okay, so now we go backwards to the questions and we are going to do them all. चलो guys, एक एक करके करो. What is the major product? This is question number 1. Major product formed in the following reaction is. So first of all, tell me, ये कौन सा name reaction है? Yes, very, very simple guys. Which name reaction is this? Yes, the xanthate one. Xanthate pyrolysis, absolutely. So what should be the product? आप ही बताओगे guys product. मैं नहीं बताऊंगी. Okay. Yes, very good all of you. Riya, Chetan, Radhika, very good. Yes, Monica, what is the product? C. Cave elimination. Yes, Simran. So we are just going to form the xanthate first of all. A xanthate बना के हमने check करा. Do we have a syn hydrogen? Yeah. Do have a syn hydrogen on this side, not on this side. ये तो नीचे है. This is your ester, xanthate ester. So you are going to cause the elimination in this way, right? Very, very simple. Guys, तो आंसर क्या आना चाहिए? Option number C. Because this side the hydrogen is present below the plane. हमें एंटी नहीं चाहिए, हमें सिन चाहिए. सिन मतलब same side. So here you have one hydrogen above, one hydrogen below. ये यहीं से ये elimination हुआ है to give you option. Now you understand, everyone understands. To give elimination reaction, Syn Pyrolytic Elimination. अब ये देखो, major product A and B in the following reaction are. Yes guys, ये कौन सा reaction है? Which reaction is this? N oxide. Oh, very good, Ria. This scope elimination because you see N oxide hai and only heat is given, nothing else is given. Yes, Rituja, Chetan, very good. अच्छा सिमरन आप बोल रहे हो heteroatom oxidation. No, actually heteroatom oxidation is already done. पहले से N oxide है. हाँ, ठीक है. So पहले से N oxide है. But let's say if you were given metachloroperbenzoic acid, तब हम सोचते कि oxidation करना है. Already it is an oxide. This scope elimination. So scope is once again Syn Pyrolytic Elimination. Syn मतलब कि same side. I have to look for a proton which is on the same side. अभी ना this nitrogen is below and there are two hydrogens above and below in this case, right? और देखो guys यहाँ पे क्या है? यहाँ पे भी तो एक hydrogen है ना? Yes, here also you have a hydrogen. Now, what did I tell you about the cope elimination? Cope elimination will always give you हॉफमैन एल्कीन. अगर यहीं पे मेरे पास ये दो रिएक्शन ऐसे होते ना कि ये देखो दिस इज योर ऑक्सीजन ग्रुप, एक जो OH ग्रुप है वो अबव है और दूसरे वाले मॉलिक्यूल में OH ऐसे अबव है और ये आइसोप्रोपाइल ग्रुप इज आल्सो अबव. सो प्रॉब्लम इज guys when there is a possibility, यहाँ पे possibility है ना that there is a hydrogen on the same side. Yes. So if you are doing Chugave elimination by forming the xanthate ester by forming a 6-membered ring, तब एक possibility है that you might get the more substituted alkene. You might get a more substituted alkene as substantial amount in a substantial amount. So Chugave elimination will still give you more of a Sade-Zef alkene, मतलब more stable alkene, but cope तो बिल्कुल नहीं देगा, बिल्कुल भी नहीं देगा cope elimination. ये देखो यहाँ पे एक पॉसिबिलिटी है हाइड्रोजन की अबव द प्लेन, यहाँ पे भी एक अबव द प्लेन है, ठीक है. You are going to get the Hoffman alkene only. Okay, where is it? Yeah, this one. This is your Hoffman alkene. What about this one? One hydrogen is below only. Yes, one hydrogen is below over here. So ये क्या कर सकता है guys? This is also going to make sense. Yes or no? What do you say, guys? Does it make sense to all of you? Yes, very important question. So C is your correct answer. Cope elimination reaction. We move onwards to another one. ये देखो. Major product formed in the following reaction is. Which reaction is this, guys? Yes. Beckman fragmentation. अच्छा. So, alright, very good. You have identified this reaction. So, अभी product भी बताओ guys. What is going to be the product? Going to be the product in this case? What I've already done is I have directly made the oxime. क्या किया? I have directly made the carbonyl into an oxime which is a substituted oxime. तो मैंने OAC पहले ही लगा दिया so that I can directly show that this step, these two are anti-periplanar to each other. तो ये क्या करेंगे? The bond is going to open up in this case. Alright, and you get a carbocation over this carbon. Once again, guys, is it a 3 degree? Is it a 3 degree carbocation? Absolutely it is. Now, in the presence of the acidic medium, what is it going to do? It's going to lose a proton from two of its places. देखो ये CH3 है, यहाँ से भी proton loss कर सकता है, यहाँ से भी कर सकता है. right? But definitely in the presence of acid, it will give you a more substituted alkene. Why guys? क्योंकि ये कोई Syn Pyrolytic Elimination तो है नहीं. Alright, it is a simple alkene and a simple reaction mechanism, right, in the presence of acid. So you are going to get this molecule in this way. ठीक है? जैसे कि for example, yes, good morning Abhishek. For example, हमने ये बना लिया, right? There's your CH3 over here. Alright, so onto this carbon, अच्छा, just 1 second. The CH3 has to be on the upper side यहाँ पे, and this carbon has to have both of these methyl group, और ये वाला जो carbon है, this is going to have the ethyl cyanide in this way. So your answer is option number A. Okay, yes, very 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 important this one, Beckman fragmentation. चलो एक और reaction करते हैं guys. Let's do this one. What is this? Major product formed in the following reaction is. Now what does this reaction give? एक बार नंबरिंग कर दो. श्योर. ये देखो क्या हुआ सिमरन. फ्रॉम दिस कार्बन, लेट्स से इफ वी आर डूइंग द नंबरिंग, या फिर देखो ये जो टॉप कार्बन है ना, यहाँ से नंबरिंग करते हैं. ओके, फ्रॉम हियर फर्स्ट वन, 1 2 3 4 5, 5 कार्बन ओनली, सिर्फ चेन पे नंबरिंग कर रहे हैं, राइट, रिंग के ऊपर. सो 1 2, 2 पोजिशन पे डबल बॉन्ड है और मिथाइल ग्रुप है. 3 4 5, ऐसे कर दिया नंबरिंग. Yes, done now. Chalo. So now this one. Major product formed in the following reaction. What do you say about this, guys? Which reaction, guys, and what is the product? Done? हाँ, ये Beckman है. But Beckman का product, guys, lactam. That is also okay. It is going to form the lactam. But which lactam is it going to form? That is also important. No, ये कौन सा lactam बना रहा है? Yes. All right. Let's do the mechanism, guys. And even if you don't want to do the mechanism, यहीं से देख लो. OH becomes OH2 positive, and then the trans group is going to migrate. ये है ना trans group बड़ा वाला. This is going to migrate. ये ऐसे nitrogen. All right. Very good. Yes, very very good. Okay, एक bond की कमी हो गई शायद. Yes, there should be one more bond over here. Since it is a 7-membered ring, ऐसे करके लिखेंगे इसको. Okay, so answer is option number D. Very nicely done, all of you. Very nicely done. And one more question that we do today. Okay, this is not fragmentations. This is no. और fragmentation में carboxylic acid और amine तो बिल्कुल नहीं होता है. ठीक है. So this is also wrong. This is a product of the wrong rearrangement. That is the less substituted group is migrating, which is not going to happen. So D is your correct answer. All right. Next question. The following reaction, guys. What do you see? You see hydrazone, and that also you see tosyl hydrazone. Yes, so what should be the correct answer? Yes, it is Shapiro. It's Shapiro, no doubt. Right, guys. What is the correct answer to this question? You have to take care of one thing. Yes, see, you are going with problem. You have to take care of one thing. That is what it is. Shapiro reaction में भी देखो क्या देखना है. You are having tosyl hydrazone already. It is from two equivalent butyl lithium. This proton and this proton will be removed. There is a hydrogen over here as well. Methyl के carbon के पास भी hydrogen है, but this is not removed. The more acidic one is removed. All right. So this is the system that you are getting. Why? अच्छा ये tosyl group remove हो जाएगा यहाँ से. It is not there. Why are you getting this system? Because this is a more acidic proton, also less hindered. तो यही attack देगा यहाँ पे. And by the final attack, okay, you get a carba anion on this carbon. और ये carba anion क्या करेगा? DMF पे attack करेगा. It is going to be formilated. C is your correct answer. So from the Shapiro reaction also you are going to get the less hindered alkene या फिर less substituted alkene. Okay. So this is once again very important. C is your correct answer. Shapiro reaction में less substituted मिलता है. Bamford के अंदर more stable या more substituted मिलता है. We will continue this the next session. We have done plenty of important reaction which have been asked directly and multiple times in your examination. ठीक है. So yes, just study all of these guys. Very important they are. और मैंने आपको बता ही दिया है already that what are the classes which are going on right now on Unacademy, free sessions plus session everything. Tomorrow Sunday we will have one more strategy discussion in the morning only 9:15 a.m. Important topics of organic and physical. You can directly enroll. Class बन चुकी है, enroll कर लो, register कर लो, नहीं तो आप group में मैं आपको share कर दूंगी. Okay. And yes guys, I will see all of you at 10:30 in the plus classes. Till then, bye bye everyone. Have a very nice day. Very soon I'm going to see all of you. Okay. Chalo, take care guys. And if you are liking this series, then please give some comments and share it with your friends also. All right, if you are liking it, if you want me to add something more, you can suggest. All right. Chalo. Chalo, bye guys. Yes, Chetan. Me too, I'll also do the same. So bye everyone.